same process, you are going to have multiple thread. So because of that, so one of the example of such a multi-threaded, nowadays a lot, most of operating systems use multi-threaded, especially the hyper-threading is required for the virtualization and the virtual machine. So you need the Java program. So Java is a program language that will be one of the motto, the slogan of the Java is compile once, run everywhere. Yeah. So how can we do that? Because as we discussed the last few weeks, it doesn't make sense. So whenever you have the new hardware, new CPU, they have the different instruction, it's totally different. The environment, so we need to compile again. But Java is the different. How?
Virtual machine.
Yes, that's based on the virtual machine, which means they have their own, no matter what types of CPU hardware you use, it's their own memory area. This is called the JVM, Java Virtual Machine. So, for example, even though you do not know how to the code for the Java, so I don't know anything about SDK, but once you download the JRE, Java Runtime Environment, so that makes the environment where you can run any Java application. How? So this is the Java own area. Okay. Then, so this 512 megabyte is the default, but you can increase in your setting. Okay. When you run the Java application, then this one, when you check the process ID, like the PS command, it has only one process. Then, when you run I have the A class 5, so Java application, when you run this one, it will be running inside as a thread. So you cannot find this Java application ID, processor ID, because it's a JID, Java Virtual Machine ID, and under that, there are number of threads is created. Because of that, so I ask you not to use the Java because it doesn't make sense to create a new process. Even though some of the Java package, so actually the pretend to create a process, but you never create the process instead of creating the thread. In other words, it's much easier to do multi-threaded programming using Java. Whenever you run the program, it's actually the Java. Also, you can do the user thread. It's a Java thread, it's the server-side thread, but you can create your own thread also using Java. So we will see later. Yes, question.
Oh, but doesn't the JVM keep track of how many threads are running in the JVM?
Oh yes, so you can actually create multiple Java threads. Then even you can communicate with each other.
But if you create more threads than CPU, can you create more threads than
CPU? Yes, we will discuss this. So for example, if we have only the 2 core, 1 CPU, 2 core, can I create the multiple thread? Yes, we can create the multiple thread, but you cannot get the full benefit of
yeah,
that.
okay.
Yeah.
So
we will talk about the later multi-core programming. Well, the long time before is called the parallel program. What we did during the parallel programming, actually we divide the job and run separately. It's a multi-programming or parallel programming. Very, very hard. But if we are using the multi-threaded programming with the multi-core, operating system assign the thread for each core. Then we don't have to, user side, we don't have to worry about too much. So it's not fully the 100% utilization, but it's better. So the important thing is whether we can create the thread for each task or not. So that is the thing. So definitely we can create the more thread but we cannot get the full.
I see.
Roughly the 3 times of the CPU or core you can create. So for example, if you are using the dual core, you can create the fixed thread for parallel programming. Then you can get the full benefit. You don't have to create just 2 threads. You can create the 3 times of the number of core. May get the best the performance. It's lovely. Lovely. Okay, so then we are going to start the thread. So which means if you understand the process data structure, it's much easier to understand the thread. So motivation I already explained about why we need such a thread. Instead of creating process is a really expensive job in terms of resource. You need to find the available the space and move the there exists the data structure layout as we have seen before. It has a data area, text area, the global variable. What is the heap area, the stack, and so on. It's a very detailed data structure. So you need to move on every time. So it takes a longer time. But not all such a function are needed in such a detailed order. So when I create the multiple processes, they are exactly the same thing. Do I need to create the same thing? Instead, to share as much the resource as possible. Yeah.
These threads have to be allocated inside the memory address of the parent process.
Oh yes, but as a user, you don't have to. So we will see the thread programming. So you can just create the thread, which part should be thread, the part. Like for example, so I write the sum 1 to 1 million. Okay, so it takes a long time. So we are going to separate the 1 to 1,000. And the 1,001 to 2,000, 2001. So we create the 1,000 threaded. Then but each thread has the same algorithm. So you create the thread programming for the sum. Then as an input, 1. So you can give the argument, input and out at the starting and end. Then create as many threads as possible.
But these instructions have, so for example, when I make the Java, right? I create a memory address, right, of the process, of the JVM, right?
You, as a user, you don't have to.
Right?
There it is.
So
Yes.
if I kick off the thread has to live inside this block.
Oh yes, right. Inside the Java virtual machine. So it's inside the Java machine. That's the Java.
What about the OS? So if I have a
So for example, we are going to use a P thread. They allocate the available resource, but this is the size of the entire process. But if you create the thread might be much smaller than this.
So it can be outside
Yes.
the process.
Okay.
Yeah. So this is the motivation. So then we can do the benefit. Why we need the thread? We wanna save the resource, which means we wanna make the better performance. Okay, so that's the idea of the motivation of thread. So what is a thread? So thread is as the name implies, it's a thread of instruction, but we are going to share as much information as possible between the thread and the work processes. So what kind of information that we can share, what kind of information we cannot share among the threads. So for example, so stack pointer. Do you think the stack can be shared or it cannot be shared?
No.
No, why? So stack is,
Local variables.
yes, it's a local, which means it's even though we are using the same, the summation, the thread function, but their value will be different. So this thread is 1 to 1,000. This thread is 1,001 to 2,000. So we cannot share the stack. What about the register?
The register?
Yeah. Register is a storage,
Yeah.
right? Each student has their own storage. Even though they are identical, their value will be different. So register should not be shared. So which means the thread has their own register information. And scheduling. As you asked just before, what if we have the more thread than the CPU? Which means we need to take the schedule. So there is a schedule. specific information, which cannot be shared. So set of pending and the block signal and thread specific data. So these information are the needed for the thread. The other information like the global variable and also the text program part, the code instruction, we don't have to assign. Instead, we can share such a thing. For better understanding, we can see this one. So this is an illustration of the PCB data structure. What is a PCB?
Process
Control block. It's a data structure where we can keep all the information about the process. So, for example, pointer, process state. Process state means new, ready, run, terminate, so on. Process number is a process ID. Each process has only one unique ID. So then, program counter is a starting address of your next address for the next instruction. And the register information, memory limit, the list of open file, and so on. Here, as discussed just before, this information here, so this information is a thread specific. So, this the red box. We can, when we create the thread, so we can share the OS information, we can share the resource information along the threaded, but when we create the thread, we don't have to create the entire, instead we can allocate the space for the program counter register, which means the thread specific information. So for better understanding, it will be like this one. So when we have this is like the thing about the data structure for the process, one process, process 0. When you create the thread, so one thread will have only this part. The other information will be shared. And this will be somewhere in your memory. In case of Java virtual machine, it's inside the JVM. And this one, if you create another, the thread, this thread may be somewhere, this one. Then they share this information. So this is the idea of the thread. So why do we use such a thread? So first, save resource. Then, it's a parallel programming. So they are acting as the independent process. So we can do the printing and read the data. For example, here, this is one process. So this is one process. So while we are printing, I want to do my job, to read the data at the same time. If they are in the same program, one thread, you cannot do. So as we discussed last time, if there is any input and output, what happened in the process? I/O wait. You need to wait until somebody bring the student file. Whether if you the print, I cannot do the next job until print is done. So it's a sequence. But if you are using thread, they are acting independent process. So you can do the print as well as the read. However, what if I do not have the multi-core? What if you have the single core?
Concurrent.
So they are the schedule.
Yeah.
So you cannot get the full benefit. The rule of thumb is usually 3 times of number of core, so you can get the full benefit. So this is in case you have the single-threaded process, so this is just normal. But if you have the multi-threaded process, the threading programming, code, data, file, those are shared. But each thread should have their own register information, stack information, program counter, and then they can process their own instruction. Okay. This is an example of the POSIX thread. We will see how we can implement the thread. So Java provides the thread library, POSIX provides the thread library, so on. So this is the example of the POSIX thread. The POSIX thread is just one process. The left-hand side is a single the process, single thread. The example, as we have seen this one, we have the stack area, text area. Text area is code part, and the data part is the global variable. But if we create a multiple thread, so there the code part is the thread 1 and the thread 2. They have their own the stack area, local variable, right? But they are sharing the programming part, text area, and the global variable definitely should be shared like this. Then, how can we create such a thread? So, operating system provides a multi-threaded server, which means it's a client and server architecture. For example, when you, instead of the normal, the process of the creating the new processor in operating system is you are going to use a system library, fork and exe, which means kernel side. So the operating system mode is changed to the kernel mode, then operating system is in charge of to create, finding the available resource during the fork, and the load, the copy, the program code during the exe. Instead, the multi-threaded programming can be supported by the multi-threaded server architecture, which means there is a server side who is in charge of to create the thread. So that is the server, multi-threaded server. Then user side, you are the user program who wanna use the multi-threaded programming. Then you can request to the server, I need the thread. Then the server allocate the thread specific the area and information. Then the user can get such a the thread part. Then the server keep receiving the request. So this is called the multi-threaded server architecture. If you are using Java uses such a multi-threaded server architecture. Okay, what are the benefits using such a thread? So first, the resource sharing. The second part, resource sharing. Definitely, because we are sharing some part of resource, so we can save the memory resource. So it's a resource sharing. The responsiveness, the first one. What does that mean, responsiveness?
That if a user requests like some service, the server can also, let's say that I request something for the server and Eric wants something for the server. Like the server, Eric doesn't have to wait until the server is done for my request. He can just skip over a thread and then another thread server.
Right. Then the plus one more thing is simply, so we have the multi-thread from the one process. So process thread 1, thread 2, thread 3. This one, something happened. So error. Then still the other thread will be running. So this is the, however, if you have the one process thread, if something happened, so your entire process will be the terminated. So this is called the responsiveness. So because that's the generic benefit of the parallel process. Okay, and economy, because we can share the resource much cheaper, so than the creating process. Scalability is from the parallel processing. So if you have enough the hardware resource power, so you can get the scale the multi-parallel processing. So that is a scalability. So this slide shows the benchmarking test. So there are two types. One is the fork, which means creating process. Yeah. Another one is, so fork is a creating process, pthread create is a creating thread. So we'd like to compare. So depend along the different platform, which means the CPU. And if you see that this part is the creating process, the right hand side is creating thread. Roughly, if you compare that, so for example, total 53, 6, 40, 0.97, which one is better? creating thread is a shorter time. Roughly, it's a 30 times faster than creating process. To test this, definitely they create a lot. For example, 1,000 process, 1,000 thread. Then they check this is not world clock time. It's not stopwatch. Instead, you can see the real user sys. So, what is the real time? What is the user time? What is the sys time here?
I'm guessing real time is for the whole process.
Whole process is a time. What kind of time?
So second, right?
Second,
Milliseconds.
for is the world clock time or stopwatch time.
I think it's stopwatch.
So in any case, so in computer science, we are not going to use the world clock time to measure the performance.
Or the clock cycles.
Clock cycle is a CPU time. Always we can check the CPU time. But there are different types of the time. So first, we need to understand the user and sys time. I think that you guys can guess what is the user time, what is the sys time.
I'm guessing user is user input
User input,
time.
Good
And
guess.
system is system.
system. User is a user time, sys is a sys time.
I mean, maybe it's like how much time it takes for the user to see a result, and the system is how many times for the system to allocate the resource.
Oh, close. Do you remember the dual mode?
Oh, yeah.
Dual mode?
Kernel mode and user mode.
Yeah, so operating system has the dual mode. So dual mode is the time, then the user, the print, or the whatever, then the kernel take over the write, the system library and return. So this time is the user time, and this time is for system time.
I see.
So you need to, when you assess your system, you need to figure out whether my system is slow. So when you check your system, whether it's because of the user mode, whether it's because of the system mode. So how do I check? How do I check?
By comparing which one takes the longest.
Let me. Where's yeah, here. Stop. Yes. So this is the operating system. So when I think to monitor your system, top is the best command. So if you run the top, it has the process. There are a number of process 475, and the two running and so on. CPU usage. You can see the user, sys, and idle. Real is the summation of the user and sys. So you can take a look at the user part and sys part. 70%, 75% right now is used for user mode, this part. And 12% used for system part. And the 70% is idle. So I do not have 100 CPU. Instead, this percentile means the 10% is for the user mode, and the user mode may be here, and system mode here, and the other will be idle. Idle is the 70% roughly. Okay? And the 10% will be used for the user, and the 30% used for sys. Roughly, so rule of thumb is the ratio is 1 to 3 is the best. This time, because we have enough, the CPU resource is not a problem. But in case your system is slow, check whether usually, if user mode is too much, like you have a lot the graphical user interface or the mode, your program part. So this part will be very higher. So for better performance, it is recommended to have the system kernel mode. Have the 2 to 3 times. 1 to 3, 1 to 2 is ideal. Okay. Then you should have the idle. If you do not have idle, 0%, which means your system might be infinity loop. Okay, you should have the something, the idle percentile. Because that's kind of the breathing.
Yeah.
So if you do not have to take a breath, you cannot survive. Even though your all entire energy doing study, but you should have the rest. So you should have the idle. So 1 to 2, 1 to 3 is the ideal, but you should have this one. So we can check this. So based on this, the CPU time, thread usually 30 times the faster than creating process. So this actually the top command provide a lot of information. So load average is the average number of running process. Oops. Average process of running process, and we will see the more about the memory, the usage, after we cover the memory management part. Okay. And also, if you are using the Unix, the system, the macOS does not support the VM state, or the NP state is a multiple process. I do not have. I tried to find the application for macOS, but unfortunately macOS does not support. Instead, I need to install from the source. But if you are using other Linux system, their bash shell support NP state or VM state. This is also very useful command to see the when you have the single processor or you are going to consider all the processor as a one VM state or multiple NP state. And giving to every 2 seconds show the status of your multiple processor CPU. So this is very useful. The command. You can see the right hand side of this command is for the real time, sys time, and the user time idle information will be given. This one has a VM underscore state. So similar as the VM state, it's slightly different. So that's and also not easy to see. So if you are using the other Linux system or the Unix system, please test with the VM state or the NP state. And then what happened? Oh, a student didn't see. Let me show, because I pause. So once again, I'd like to show the example of top. And if you see the top command, so you can see the CPU usage over here. There is a user mode and the sys mode and idle. So 20% used for the user in terms of dual mode. So it's a user mode, the instruction, and the sys mode is kernel mode, the instruction. So ideally, so 1 to 2 or 1 to 3 ratio is good for the system. Then the idle should have a certain portion of the CPU resource, which means should have the breathing time for the system, like that. Okay, so changing. So this slide shows how the benefit of using the thread. Okay. Then, how can we use such a thread for the multicore? So it is called the multicore. The programming idea is for if each core take the one thread, so we can get the benefit of the parallel processing, so parallel programming. To do that, the long time ago, when we had only the single core but multiple processor, CPU 0, CPU 1, and so on, CPU n. We need to divide the job function for each processor. Same thing for the core. So it's very hard to design and separate the job in the programming. Instead, nowadays, we can create the one thread programming. Then, operating system is in charge of the divide the job, balancing, and so on. That is SMP architecture, symmetric massive processor. Even though you have multiple processor, but logically, they are considered only one CPU. Then operating system supports such a thing, like the dividing the activity and the balancing job and the data splitting and the dependency and so on. Then we can get the parallelism. Also concurrency. Same time you should run. So concurrency control will be managed by such a server side. So nowadays the user doesn't have to worry about such a multi-core programming. Instead the server side it will manage. There are two types of multi-core programming. One is data, from the data point of view. Another one is a task. So traditional, the parallel programming focus on the task parallelism. So our goal is to divide. This is the summation. This is the display. This is the spelling check, like this one. You are going to divide the job by the core or the CPU. But nowadays, we have only one thread programming, like the summation. So it's for I to the I plus 1000 and the sum plus sum, sum, like this. Only simple, not simple, only one, the thread programming part. Then each core has their own data, and run, and eventually add up. So for example, if you took the Hadoop class, so map reduce programming, mapping is a data locality. So you are going to submit only one algorithm, program, application, but it will be, it's not thread programming, but for example, it's a data parallelism. So nowadays, the data parallelism is much more important. So the slide illustrates such a data and task parallelism. So data parallelism focus on you are going to run the same program but for the different data. But the task parallelism, you are going to use the same data but different task, different function. So there are two types of thread in operating system. You can easily imagine. So because we have the dual mode of the operating system, so user side the processing and kernel side processing. So similarly, user side the thread and kernel side the thread. So user thread, there are three. So for example, if you already done I did the thread programming in my Java class, that is user thread. Okay. Most of the students, even including me, I never did the server side thread programming. It's provided by the operating system. So operating system automatically run such a server side kernel thread. So user side the user thread, there are three major library. We can use such a library. For example, here. So Java thread, so if you did the Java thread programming, if you already implement, it's a Java thread. Also, POSIX is the Linux or Unix, the library for your thread. However, POSIX pthread is not the implementation of the thread programming. Instead, it's more like the specification, guideline. So each the version of operating system, like for example, Mac OS use the pthread, that means their own thread programming implemented. And also, if the CentOS follow the pthread, which means based on guideline, they implemented their own library. So pthread is more like the specification, not implementation. But the Java thread, Windows thread is implemented by the operating system. That makes sense because the Linux has a lot of different variants. The Red Hat Linux, the Ubuntu Linux, the CentOS Linux, they have their own pthread library. Some of them are compatible, but they may have the different name of system library. Okay. However, if you are using Java thread or the Windows thread, their thread is already implemented. So in your programming, you can use such a thread program. We will see the example of the Java and the Windows and also POSIX example. Oops. So, because of the characteristic of the operating system, user mode and kernel mode, we have such a the user thread running on user space and the kernel thread and the kernel thread. A kernel thread running on the kernel space, the kernel mode. Which means, do I need to specify the kernel thread? User thread I can do using the thread API. But what about this one? So we need to, when you run one application 8.0, that includes the thread programming, even not thread programming, I do the single thread, just normal process, but when your program is going to the kernel thread, it might be multiple thread, kernel side. You may not realize. Okay? So which means we need to, when we design the operating system, we need to consider how to allocate, how to create the user thread with the kernel thread. So there are different types of architecture, like the left-hand side is the user thread part, and right-hand side is the kernel thread part. So in simple case, it's a one-to-one. When you run a.out program, one user thread will be created, then if needed, during the kernel mode, one kernel thread will be allocated. So it's simple. However, nowadays, the most of operating systems support the kernel, multiple kernel, the thread. So which means it can be one or the many. And so it's depending on the how many the user thread, how many kernel thread. It's a many-to-one architecture, one-to-one architecture, and many-to-many architecture. So for example, many-to-one. So in my Java programming, I create the multiple Java thread. But in kernel side, it's still one kernel thread will take care of all the requests. So it's a many-to-one. It's a simple. You just can create as many threads as possible, but during the kernel mode, only one thread will take care. Okay? So like for example, all the Solaris, the green thread, use such the model, and the GNU portable thread is using this one. But as you can see, the kernel side is still the single thread. Even though you have the multiple processes or the multicore, you cannot get the full benefit of this during the kernel mode. So one-to-one is a dedicated. Only one user thread will match to the kernel thread. They are communicate and work. So during the user mode and the kernel mode like that. Now another process like this. So you can get the parallel multicore. So when you run the multiple program. However, in single program, you cannot get the full benefit. So like for example, Windows use this mechanism and the Linux. That's the reason sometimes when you run the multi-thread programming, it doesn't look like the linearly increase the scalability when they are using one-to-one. Okay? So one-to-one. So the architecture. So many-to-many is the multiple user thread will be taken care by the multiple kernel thread, but you should schedule which one will be mapped to the which kernel thread. So thread file package on Windows used such a mechanism. So nowadays most of the system is a two level. Many-to-many, also one-to-one. Okay? So one-to-one is because this the scheduling definitely overhead. So we are going to use the both of them, and then depending on the user process type, so it can be one-to-one. Otherwise, it can be many-to-many. So how can we create such a thread? So operating system provides the thread library. So you can use provide the thread library to create the thread program. First one is a P thread. It's a POSIX thread. So POSIX thread is kind of standard. So each operating system who follows the P thread can implement the thread library. So most of the Unix system and the Linux system and the Mac OS, you follow the POSIX, the P thread library. Some of them are compatible, but not always. So you need to recompile, or you need to use a different name of a system library. So this is the example of the POSIX thread. So you need to definitely include in C or the C++ programming. And here. So this is our thread programming part, which means I'd like to sum, okay? This is the logic. This is your program. So sum of 1 to upper, the input value. So if the input is the 1,000, okay? So 1 to the 1,000, so 1 plus 2 plus 2,000. This is the thread programming, okay? This is the thread programming. So name is a runner. Then this you can create the thread, the P thread init. Okay. Then using P thread create, but what will be the threaded runner? Runner is the thread programming part, summation. Okay. So this part will be threaded. So you can create how many? This time. So you can give the argument to 1. Let's see. Next. Let's see. The P thread join. Here. Here. How many? Number of threads. So this P thread join will be done depending on the number of threads. So you can create as many threads as possible. Then so you can create the P thread and the join. Then the P thread join specify how many. So this is a thread example. The Windows is a let me clear. So this is a Windows programming. It's exactly the same algorithm. It's a summation. So we'd like to do the summation part up to the upper part. Then here the Win32 API provides a create thread function library. Then this one has the similar argument like the summation and the thread ID. Then you can here's the create thread. To create the thread programming. What about the Java? Java you probably did. So Java. So there is a runnable interface. Okay. So this is a runnable. Then you can create your thread using the instantiation of the new thread. Okay. Then you can join. So if you remember that this client, your program request to the server architecture, then this one receive create a new thread. And if the new thread is allocated, the instantiation means is create the thread, which means inside of your Java virtual machine, the memory will be allocated, and this one will be running like this. So then finally execute, then will be running the Java thread. Okay. So sometimes I assign the project, like the create the thread program and communicate each other. Yes.
Is there anything like a callable on, because in Java threads cannot return any result to the pattern. Is there any such a thing for the
So how
OS?
can you communicate each other?
Just leave a memory.
Thread.
Well, a memory location that both
You can
runs.
use RMI. So that we discussed the last time. So among the process, you are able to communicate. At the time, Java support RMI protocol to communicate. So that is the way to communicate between or among the thread. Okay. I did the RMI, the programming, only in the classroom when I was a student. After that, I didn't, but that's the most popular one for the communication. Okay, so I think today we are going to start here. Okay, so then the rest of the part will be discussed on the Wednesday. Okay, and also you guys need to, we will have the exercise lab with the video recording. Okay, so GA will provide recorded video on the playlist every time, so that you guys follow the instruction on the YouTube, then you can submit your proof of exercise lab with the screenshot. Okay, so today I'm going to start here, then we will continue on Wednesday. Okay. Any question from the Zoom? So please, yes, there is. Let me start here. Where is the question? Yes. That one, we can do it on. You mean the exercise lab one?
Yeah.
Exercise lab. Please use the virtual machine. Okay. So that's your practice.
Yeah, so you just put the command
Yes.
screenshot.
Yeah. Please use the created virtual machine on the GCP, and you guys can be familiar with the command line interface using the Linux. I don't think it's a big problem. If you cannot connect from your laptop using SSH or the VNC, you can directly connect on console. Okay, it will be fine. Okay, so any other question? Okay, thanks so much for you. Oh yeah. So you mean just the command line or using the fork and exe program? So you can see all the directory using the other option, like the A option shows the all file and directory, and the L option is the details. So why don't you use the options to see the directory? The good question. So if threads are created for multiple process, still they share the data? Yes, they share the data. Because it's on the memory. So think about our main focus is to reduce save the memory resource. Because of that, we are going to create the thread structure that share as much information as possible. Then the CPU can access different threads, different memory locations. So even though you have the multiple processes, it makes sense. Okay. So thread is not the CPU structure. We cannot touch a lot. We cannot change a lot the CPU, the processor structure. It's manufactured. Right? What we are doing is mostly memory. That's the reason memory, understanding and or implementing the memory structure is the most important part for the computer science student. There is not much room to change the CPU or the hardware part. But we can do a lot for the memory structure.
Yeah.
Like we can consider something memory as an object-oriented programming. So when I explained about what is the object-oriented programming, so sometimes it's how to handle the memory efficiently. So that is the reason the thread is the memory structure, not the CPU. Oh yes, that is a good question. The Viper Rana asked about what isn't the data of no use for that thread, as they don't need any data regarding other process. So because of that, they have the thread specific data. You can manage the thread specific data on the area. So we will discuss that part a little bit more in the next class. It's a thread specific data. But problem is, what if among the thread they need to share? At that time, you need to communication among the thread. At that time, in case of Java, provide RMI protocol and so on. Okay, thank you.